I'm sure that you'll remember that in part 2 of the video I spent a long time telling you about how wonderful 3D CAD was, and if you use 3D CAD everything fits. And having told you that, of course I went ahead and I made a mistake because I didn't actually model some of these components up properly. And yeah, it caught me out. So basically what I did was the actual vertical columns, I've actually cut these too long. Well, it's not that I cut them too long, it's the fact that I didn't allow for the depth of these corner brackets. If you look at my model that I created, I didn't include for these corner brackets, and they actually take up about 5mm. So unfortunately I cut all of the corner columns. I cut them 80mm. Really they should have been 70mm because I didn't account for the corner brackets. So I went back out to the garage. I've got some more corner brackets here. I'm going to install them and then hopefully everything will be a good fit. So I'm going to do that now. So now we've reduced the height of these 4 vertical columns, hopefully when I drop the top on top now, the actual die bond material is going to fully engage with the slot in the rail, and it shouldn't rattle about as much, and we shouldn't have a gap at the top here, which we did before. So fingers crossed that goes okay. And that seems fine to me. So even though it is only 3mm material, it's actively being clamped now because these rails are kind of pulled down onto it. So again, yeah, that gap's gone now, so it's a good fit. Now the next mistake I've got to put right is the fact that I actually cut this panel for a GX20 style connector, whereas this one is a G18. The difference is actually the diameter of this part. This part that I've bought is actually smaller. Now of course I could just go ahead and I could actually buy the correct GX20 part, but seeing as I've already spent money on these, there's no reason why I shouldn't use them. So I think what I'm going to do is I'm just going to take my 3D printer and I'm going to actually just print out some kind of little adapter, something which will get sandwiched between the front of the connector and its locking nut, and it's just going to take up that space that we don't need and stop it rattling around. So let's do that. Yeah, it's actually measuring about 11.63, so I'm guessing the nominal hole for that would have been 12mm. Okay, let's go and model up some blanks now on Fusion. Yeah, I think that's going to be fine, and it has saved the cost of just buying another GX20 6-pole connector. As you can see on the bench, we've got this cornucopia of pneumatic fittings here. Now of course we call these things pneumatic fittings, but one thing that I've been fairly unable to do is actually get most of them to fit together whatsoever. So it seems that when it comes to pneumatics, I don't really know very much about it. What I can tell you is that all these pipes are different sizes, everything seems to have different thread sizes, and although these all should fit each other in my mind, practically they don't. So I bought 2 lots of pneumatic hosing, so I've got some, I think that's 6mm, and also some 4mm flavoured. Now unfortunately they don't appear to fit any of my other fittings. So we've got an air regulator here, which we'll come on to shortly. We've also got the squirty thing, not sure what we should call that. Is that the misting head? Something like that. And that comes with one of these push connectors on it and a little check valve here, a ball valve to actually turn the airflow on and off. Well, we don't actually need this check valve, this little handle, because we're actually going to use this electric solenoid to switch the airflow on and off. So I think we can actually remove that, because it's not much use to me, because yeah, the pipe that I've chosen doesn't fit anyway. These should just push in and lock. So hopefully I've bought some other fittings, which again not sure what they are. It says BSP at one end and I think 6mm at the other, so hopefully they're going to fit this pipe. Hopefully, yes they do. Now is this going to screw into here? Fingers crossed. Okay, well it appears to fit into there, so in theory we can now actually plug this into here. Is this going to fit this at this end? Okay, good. So yeah, we're going to install this on the milling machine. We're going to connect this air hose between this solenoid valve and this nozzle. I don't want to connect this air solenoid valve or our nozzle here. I don't want to connect that directly to the compressor, mainly because the actual compressor itself outputs too high air pressure, and I think I might actually damage this valve. But the other thing is, if we actually have too much air coming out of here, it's going to blow everything away at quite a high rate of knots and generate shrapnel flying around the workshop. But it is actually quite dangerous to have unregulated and high pressure air in the workshop. If you've ever looked at injection pressure injuries where people have managed to inject themselves with either compressed air or maybe hydraulic oil, they really are terribly horrible injuries.
It is common that smaller particles or debris bounce back towards the operator. Even tiny particles can cause serious injury if it hits the operator's eyes. Or if the compressed air is blown directly against your body, the compressed air can get underneath the skin and into the bloodstream.
And I think I've seen some guidance from the American safety, I think they call it the OSHA group in America. They say that any kind of like pressure line should be limited to about 15 psi. So to help me do that, I've actually also bought one of these pressure regulator valves. So again, I intend to connect one side to an air line which is linked to the compressor. So bought one of these quick connectors here which will plug onto my air line, and of course I've been totally unable to remove this fitting that's on here. It's got some form of thread locking stuff on it. Whatever they use seems to be tough as coffin nails. Can't get that off, so we'll have to do that later. And on the other side of it, I think this must be an 8mm fitting, but unfortunately it won't fit my tubing again because I bought the wrong tubing. But I don't particularly want to go out and buy some 8mm, so I'm going to try and change the fitting on here to one of these, which we demonstrated earlier, should fit my tubing. But I am just hoping that we can get these things off because they've been installed really tightly. So of course I have managed to break that fitting off, so yeah, that's going to be fun trying to repair that. Now I'm sure some of you will say that, oh, just put an Allen key inside, because it does accept an Allen key, but you put an Allen key inside and twist it, and of course it just rounds out the head because the material is made out of sheet metal. It's not actually like a recessed socket. So yeah, I don't know what I'm doing wrong, but I'm interested if you want to leave it in the comments what should actually fit these. I don't know. Ow! Ooh, that's going to hurt. My main problem is I'm just having trouble holding this thing, and of course the reason I'm having trouble holding it is I can't put it in the vise because however I try to grip it, this gauge is getting in the way. Now of course you might go, why don't you just unscrew the gauge? Well, I think if I try and unscrew the gauge I'll probably just end up wrecking that as well, because it's no doubt covered in the same thread locking compound as these other things are. Well, bum holes. Well, I'm afraid I did have to resort to getting rather medieval on it to get this thing out. A lot of bashing and banging, but the thread just seemed to have survived. I think that will clean up. And again, I think most of the damage has probably been done by the actual thread locker they've used on here. So God knows what it is, but it is absolutely, well, made out of the same stuff as coffin nails, I think. Well, hopefully we're on the final leg of getting this project finished now, and pretty much the last thing that we've got to do is find some way of actually fitting this coolant hose onto the machine. Now the head of the machine here, it's actually made from cast iron, and there's actually a void up inside here where I'm poking my hand. So I did actually think about just drilling a couple of holes into the side of the cast iron and mounting this, but then I decided I didn't really want to drill the cast iron, and also because of the control box under here, it was quite hard to actually get a drill in to drill it, so I decided against that. So rather than drilling the headstock on the machine to hold our coolant hose in place, I decided to have a go at making some kind of a magnetic clamp. So I went ahead, had a look through the junk drawer, and I found this old Kennedy magnet. Not sure what it came off, but I'm hoping it will be strong enough. Now there's actually not a lot of weight in this, but I'm guessing that maybe there'll be a little bit of thrust generated when the compressed air is blowing out of the nozzle here. Not sure, but I'm hoping the magnet will be strong enough. Now this is a little 3D bracket which I've gone ahead and printed, and looking at it, I've got to admit I'm a little bit worried if I've made some of these sections thick enough. The bracket that I printed has this little overhanging section which hopefully is going to sit against the side of the machine head and just keep everything aligned, but because it is overhanging, we've got some support structure that I need to just break away. Hopefully it should come away easily enough. It's always quite satisfying to do that. The part of the casting on the machine headstock that we're going to be clamping our bracket to, it's not very well dimensionally controlled because it's just a rough casting. So to allow for that, I actually cut this slot here. I've actually made it oversized with the idea that we could actually shimmy it out if we need to. Now I had just given it a quick try on the side of the machine, and we have got a little bit of wobble there, so I think we can just put a couple of washers in behind the magnet and it's just going to take up this space, help to pack it out a little bit. Oh yeah, that's a nice fit. At the back of the coolant hose you can see it's got this manifold block, and that has two holes drilled in it just to make it easy to mount. But I've just hit one little snag in that I designed this actual block to bolt onto here like this, but having gone through most of my screw collection, can't seem to find any screws long enough. Well, of course I found one screw long enough, but yeah, that was just really put there to tease me. This one is a perfect fit really. Well, actually it's a bit long, isn't it? But it seems to be the only one I've got, so yeah, you join me going through my random collection of nuts and bolts here, just trying to find something that might fit. Well, that's nice. It's even Japan black, but yeah, maybe just slightly oversized. Could probably force it through with a big hammer. Again, unfortunately, I only got one of them. Well, do you think we're going to be able to find a bolt long enough? Can you feel the tension rising? It's like an episode of Ice Road Truckers, this. Bugger. Well, that seems pretty good, doesn't it? Like I bought one. As you can see, I've gone ahead and I've screwed on our standoff pillars onto the coolant tank, and I think they're going to look quite good, aren't they? They seem to be a nice fit. Now the other thing that I've got to do is put on our little hose adapter here, which reduces the size of the outlet from the tank to something which is going to fit the input to the peristaltic pump. But before I put that on, I've actually noticed, I'm not sure if it'll come out on camera, but this the actual exit from the tank here, the outlet, it is actually kind of pointing at a jointy angle. It's pointing to the right. Maybe I can turn it around now. Now of course it's pointing to the left. Can you see it's pointing this way? I don't think that'll cause a problem, but I'm wondering if I can straighten it up by just putting some heat on the tank. It'll probably go horribly wrong, but let's try that. Let's see if that's softened it all. I'm not sure it has actually. Just going to bend this over. I'm going to hold it until it cools down. Okay, I think that's actually straightened up quite nicely. So the next job to do is actually to glue or seal this little hose adapter onto the fuel outlet. Now it is one of those types of plastic that is a little bit kind of soft and waxy, so I'm not sure how well my epoxy resin is actually going to glue onto here, but I guess we've only got one way to find out. I am concerned as well that the coolant, the chemicals in it, might also eat away at the adhesive and make it come away, but yeah, we're just going to try it, haven't we, I suppose. Just taking a look inside my hose adapter, it is actually quite polished, and again I'm not sure how well the epoxy will stick to this polished brass, so I'm just going to take this old file and I'm just going to try to just roughen it up a bit inside. Just trying to create a little bit more surface area and just create some texture so that the adhesive has something to key onto. Okay, so this stuff is now starting to stiffen up quite nicely, so hopefully we can go ahead and just get a good amount on here. And then I'm going to twist this on. I can blow through that now, so that'll be fine. As you can see, I've gone ahead and I've assembled my peristaltic pump into this plastic enclosure which I 3D printed. Now one problem that I found with this pump, because it was quite cheap, is if you look inside this you'll actually find that there's a rubber tube, and there's actually some rollers which roll against that rubber tube, and the action of the pump is a bit like squeezing toothpaste out of a tube. So the coolant will get drawn in on the right hand side of my pump here, and those rollers will squidge it round until it appears on the left hand side of the pump here and gets squirted out. But the rubber tube which is inside here that gets constantly deformed, this is actually a wear item. That piece of rubber tubing, eventually from being rolled over constantly, it will actually degrade and fall apart. So you can actually buy the rubber that goes inside these as they're a consumable item. But one problem that I found with this pump is if you actually want to take it apart to change that tube, which you'll want to do, I'm afraid you've actually got to disassemble it, because it's all held together with self-tapping screws, and you can only get at the self-tapping screws by dismantling the pump totally. So I can't really recommend this, and there is some other cheap pumps that you can buy on Amazon which will probably work better. So if I remember, I'll put some links in the show notes, so maybe choose a better pump than I have. But we have got it assembled together now. You can see that I've put a cable gland on one end, and I'm going to attach the air solenoid there, because I'm going to also use this box as a bit of a junction box. And then somewhere we've got a 6-core cable. Well, I say 6 core, I only need 6 cores, but this one is 8 because that's the nearest I've got. So this is going to go up to the mist control box that we built earlier, and that's going to supply the power to both the stepper motor and this solenoid. So put through that, I'm going to employ a very high-tech strain relief here. Sure that will work nicely. And now I've just got to join these wires together. And for this application I am more than happy just to twist the wires together, and once we've soldered them I'll just put a bit of heat shrink over the top of them just to stop them shorting out on anything. First of all, I'm going to screw down this plastic enclosure which we printed to house the pump, and it also acts as a junction box, so I think let's go ahead and screw that down first. And that just fixes on using some plastic self-tapping screws, which hopefully will line up with some holes within the back of the enclosure. It's a day later since we screwed on this hose adapter onto the bottom of the coolant tank, so hopefully that glue is set solid now. It feels pretty solid. Okay, that feels pretty sturdy. There's something I could have done better here in that the outlet for the tank, I've actually positioned it quite close to the inlet to the pump, so the tube isn't going to feed straight in easily. I should have maybe thought about that a little bit more, and I could have aligned things a little bit better. So what I'm going to have to do is I'm going to have to just put a little loop of tubing onto here, but I don't think it's going to cause us any problems as such. Is that going to fit there? Yeah, I think that'll be okay. Next I'm going to install this bayonet connector onto the air regulator just to help it seal. I'm going to use some of this PTF tape. These normally snug up pretty well because they're actually a tapered fitting. It's going to be interesting to see if this pressure regulator did actually survive my kind attention when I was actually trying to remove the old fittings. I did have to give it a fair whack and put quite a lot of heat into it, so it's possible that I've damaged it, but I guess we'll find out very shortly. I think we're on the final part of the puzzle now, which is just to install this air control solenoid, and we can call it done. So to help me install that, I've gone ahead and I've knocked up a little piece of bent aluminium just to make a bracket. I've also got to make sure that I install the air control valve the correct way around, but it will only fit one way on this bracket. I'm going to call that done. Hey, it actually fits, that's a first for me. Now to actually stop this top control box from sliding off with the vibration from the machine, I've gone ahead and I've just 3D printed some plastic clamps which are going to hold the two parts of the slotted rail together. Unfortunately, I've just spotted another connector mistake. So this is actually the trigger, which is going to come out from the CNC controller whenever the spindle's running, and that's meant to connect up to the lubrication control box up here. But as you can probably see, got the wrong size connector. It is a 4-pin, but again, I think this is a 20. Maybe this is an 18. But luckily when I bought the machine, it did actually come with this toolbox, and in the toolbox it has some spares, and I'm hoping we're going to have a spare connector. So there we go, this is a 4-pole connector. I think this is the one we want. Okay, and that one does actually fit, so I'm going to have to pop back inside and just change these connectors over. I'm going to plug in the air supply now to our coolant nozzle, and it's just a push fit connector. Now I'm only going to rig this up temporarily today because, to be quite honest, it's just far too cold to be in the garage playing around. So I'm going to leave this tubing quite long, and I'm going to cut it back to the correct length at some point in the future when I've decided how to mount this pump assembler. Let's plug in our pump assembler control cable now. Well, we're all powered up, so I guess we've just got to give it a try. So rather than control it from the CNC, going to put it in manual mode, see how it works. Oh! You can see and hear that the air control solenoid is actually switching on and off about twice a second, and you can see that the pressure regulator does drop a little bit whenever we turn on the compressed air supply, but that seems to be working. And we can also see that the stepper motor is also rotating when we turn the air supply on, so if we had some lubricant in there, in theory we would be pumping it around now. This pipe that I'm holding here, it runs up to the coolant nozzle. It actually comes out here somewhere, and I have actually spotted a potential problem. Now of course we want to be pumping our coolant down here, but what I'm actually getting is I'm getting some back pressure whenever the air supply is turned on. Now I wasn't actually expecting that because I was led to believe that there was a Venturi effect, so this should actually be sucking, but we're actually getting some back pressure. And I think what I'm concerned about is these peristaltic pumps, they really can't generate very much pressure. They're very much a low pressure pump. and I'm not sure if the actual air pressure coming back down this hose, it might actually push our coolant back, so this might not work. So I've got to admit right now I'm actually pretty worried about that. I think that we're finally now at the point where we can test our MQL system, but before doing that we've got to put some cutting oil into the tank here. Now I'm sure that there are hundreds of different types of cutting lubricants and fluids, but some of those do contain some quite nasty chemicals. Now because there's a chance that some of the oil which we spray out of here is going to get turned into a mist, and I may be breathing some of that in, I don't really want to be breathing in nasty chemicals, especially if I don't know what I'm breathing in. It certainly is a risk, and there are particular types of cutting fluids which are designed to be used with these minimum quantity lubrication systems, and in fact in general with mist type lubricators. But unfortunately I don't have any of those specialist vegetable oil based lubricants to hand at the moment, so what I am going to use is that I'm actually going to use some olive oil. Now actually, believe it or not, things like olive oil have actually been used for many hundreds of years as a lubricant, and in fact in some countries they actually use coconut oil as a lubricant on machinery. Now for me this was absolutely the hardest part of the job and the most difficult thing to source, because I'm sure most of you'll know the chances of actually finding a virgin in Barnsley are pretty non-existent. Okay, don't want to put too much in for now. I'm sure we'll have enough there to give this a quick test, because the whole idea about this is it should use just a tiny amount of lube. Let's switch on, give it a try, see if it pumps. Oh, I can see some coming down, but there doesn't seem to be very much. Let's see if we can turn the flow rate up. Oh, there she blows. Oh God, we've got a squirter. Let's see if we can turn that down. There's far too much oil coming out there. Now I think we actually need a bit more air pressure. I've adjusted the ratio of the lubricating oil and the airflow, so I've increased the air pressure just a little bit, but I've also reduced the speed of the pump, so we're going to be pumping out a little less oil. Now when this starts up, it does actually initially, it's designed to give a shot of oil to actually get everything lubed up, so when I turn it on you're going to see that, but after a few seconds that high flow rate should reduce and it should just start pumping out a very small amount of oil. High flow rate, and now it's gone to the low flow rate. So I'm not completely happy with the pre-lube at the start of the machine cycle, because it's actually delivering far too much lubricant. You could see it delivered kind of a cloud of mist, which is what we want to avoid. But actually the amount of pre-lube, the amount of time it was delivering that higher flow rate, I think it was just too long. But of course that's a very easy thing to change. I'll just have to tweak the software at some point in the future to reduce the time and to reduce the rate at which the pump runs at. To get a better idea of exactly how much oil is being pumped out in that pre-lube cycle, I've actually just disconnected the compressor, so we shouldn't be generating any mist now, but it will give us a better idea of how much oil is dribbling out of here, so let's try that again. So we got just a few drops there. It's amazing how much mist that actually made, and now we've actually got the system running at its normal lubricating rate. Let's just see how much lubricant we actually use over a 10-minute period. Okay, that's our 10 minutes done. Let's switch off. Well, that test could have gone better because our scale is actually indicating 0. So I've taken the oil that we collected and I've tipped it into a measuring glass, and that measures about 5 millilitres for 10 minutes, so that's about 0.5 millilitres per minute. I think that most of that 5 millilitres of oil that we expelled over the 10-minute period, I think most of that will actually have hit the object. It would have actually settled down and most of it wouldn't have gone into the air, but obviously some of it will have been atomised and unavoidably we would have breathed some of that in. So I actually still think we're probably delivering a little bit more oil than I want, so I'll probably again tweak the software just to make my stepper motor run just that little bit slower on minimum speed. After all this time that we've spent putting together this minimum quantity lubrication system, I'm sure like me you really wanted to see it in use on the CNC milling machine. But I am sorry to say that today that's not going to happen. It's been about -2 degrees in my workshop all day, and as evening falls it's now getting even colder. And for me that really is just too cold, so I'm afraid we're going to have to wait until things warm up just a little bit when we can actually do a full test. For those of you that have been interested in developing this minimum quantity lubrication system, all the circuit diagrams, the software and all the 3D models, they're all free for you to download, and have a look at the link in the show notes. But I think for today, until things warm up, that'll do. So until next time, bye bye for now.